So in this video, we're going to talk about how to solve compound inequalities. So let's review how to solve inequalities and graph solutions. So let's try solving this inequality and graphing the solution. So remember that the steps to solving inequalities is very similar to the steps to solving equations, right? We're going to use inverse operations to isolate the variable, but remember we have that extra rule. We have to flip the sign when we're multiplying or dividing by a negative number. So let's go ahead and solve here. So we're going to start off by adding 1 to both sides of our inequality. So when we do that, we get 2x is greater than or equal to 4. So now to solve for x, we need to divide both sides by 2. So when we divide both sides by 2, we get x is greater than or equal to 2. So now that we've solved this inequality, let's go ahead and graph our solution. So remember when we're graphing, we have some rules. So if we're using a greater than or equal to sign in our inequality, we need to use a filled in circle. So I'm going to put a filled in circle at 2, and then I need to shade the appropriate region of the line. Well, x is greater than or equal to 2 is talking about all the numbers that are bigger than 2, right? So I'm going to shade to the right of 2, and that is how you solve and graph your solution. So now let's try solving negative 4x plus 2 is less than negative 26. So I'm going to start off by subtracting 2 from both sides. And when I do that, I get negative 4x is less than negative 26 minus 2, which is negative 28. So now to solve for x, I need to divide both sides by negative 4. So when I divide both sides by negative 4, I get x. And then here I have to flip my inequality sign, right? Because I divided both sides by a negative number. So I'm going to have x is greater than negative 28 divided by negative 4, which is positive 7. So I'm going to now graph x is greater than 7. So I'm going to put an open circle at 7. And then greater than 7 is going to be all the numbers to the right of 7. So I'm going to shade in this direction. So today we're going to talk about compound inequalities, which is when sometimes we need more than one inequality to describe a set of numbers. So compound inequalities are two inequalities joined by an and or an or. So we have two types of compound inequalities. An and inequality will look like this, okay? It'll just look like one big inequality. And what this is showing is two different inequalities, right? It's saying negative 6 is less than or equal to negative 4x plus 2, and negative 4x plus 2 is less than 2. An or inequality will look like two inequalities joined by an or. So you'll always see this or when we're talking about an or inequality. So we have 2x minus 5 is greater than 3, or 4 minus x is greater than or equal to 6. So let's start off by talking about and inequalities. So how do we graph and inequalities? You're going to start off by graphing each endpoint, and the rules of endpoints are going to be the same. So open circle for a less than or a greater than, and a filled in circle for a less than or equal to or greater than or equal to. So let's start off by graphing negative 4 is less than or equal to x, which is less than 3. So I'm going to go to negative 4, and I'm going to put a filled in circle there because it's a less than or equal to sign. At 3, I'm going to put an open circle because of the less than sign. So for an and inequality, you're going to shade the region that's in between both of your endpoints. Now let's try graphing negative 2 is less than or equal to x, which is less than or equal to 5. So at negative 2, I'm going to put a filled in circle. And at 5, I'm going to put another filled in circle. And then I'm going to shade the region that's in between these two endpoints. So when we're solving and inequalities, we're going to solve them by first looking at the expression that's in the middle of the inequality. Then we're going to figure out the inverse operations that we need to isolate our variable. And then you're going to perform these operations on both sides of your inequality and then graph your solution set. So let's try this example. Let's solve this inequality and graph our solution. So what do we need to do to isolate x in this 3x minus 7? Well, to start off, we need to add 7, right? So when we add 7 here, I'm going to add 7 everywhere in my inequality. Okay, so in the middle, and then on the left and on the right. So when I do that, on the left side, I get 8 plus 7, which is 15, and that's less than 3x, which is less than or equal to 23 plus 7, which is 30. Okay, so now what do I do to solve for x? I need to divide by 3, right? So that means I'm going to divide everywhere by 3. So 15 divided by 3 is 5, and that's less than x, which is less than or equal to 30 divided by 3, which is 10. So here's my solution. Now I just need to graph it. So I'm going to go to my number line. I'm going to put an open circle at 5, and I'm going to put a filled in circle at 10. And then I'm going to shade the region that's in between these two endpoints. So now let's try solving this inequality and graphing our solution. So what do we do in 3x minus 2 to get x by itself? Well, I'm going to start off by adding 2, right? So I'm going to add 2 everywhere in my inequality. So negative 14 plus 2 is going to give me negative 12. And then I have less than or equal to 3x, and then I have less than negative 5 plus 2, which is negative 3. So now to solve for x, I need to divide by 3, which means I'm going to be dividing everywhere by 3. So negative 12 divided by 3 is negative 4, and that's less than or equal to x, which is less than negative 1. So here's my solution, and now I'm going to go to my number line and graph it. So at negative 4, I'm going to use a filled-in circle, and at negative 1, I'm going to use an open circle. And then I'm going to shade the region that's in between my endpoints. So now you can go ahead and pause the video and try doing this example on your own. So to solve 4x plus 8 for x, I'm going to start off by subtracting 8 everywhere. So that gives me negative 20 is less than or equal to 4x, which is less than or equal to 24. And then I'm going to divide everywhere by 4. So I have negative 5 is less than or equal to x, which is less than or equal to 6. And you can see that I've graphed that here with filled in circles at both endpoints and by shading the region in between. So now let's talk about how to graph OR inequalities. So OR inequalities, you're really going to think about each piece separately, okay? And then we're just going to follow the rules, the rules of open or closed circles, and then the rules of shading left or right. So what I'm going to do is I'm going to look at my number line, okay? And when I graph x is greater than or equal to 5 or x is less than negative 3, I'm going to think about each inequality individually. So x is greater than or equal to 5. Okay, I'm going to go to 5 and put a filled in circle, right? So x is greater than or equal to 5 means numbers bigger than 5, so I'm going to shade right, okay? And then I'm going to work on my other inequality. And so I'm going to graph each separately, but it's all going to go on the same number line. So then I go to negative 3, and I need an open circle because it's a less than sign. And then all the numbers that are less than negative 3 are going to be to the left. So I'm going to shade that region, okay? So you just basically think about each inequality separately, but it's just all on the same number line. All right, what about x is greater than 2 or x is less than 0? Well, x is greater than 2 means open circle at 2 and then shade to the right of 2. X is less than 0 means open circle at 0 and then shade to the left of 0. Okay, so that's how you graph OR inequalities. So when we're solving OR inequalities, we're going to use a similar idea. We're going to solve each inequality separately and then just graph both solution sets on the same number line. So let's solve this inequality and graph our solution. So I have 2x plus 6 is less than negative 4, or 3x plus 2 is greater than or equal to 14. So what I'm going to do is I'm going to take this 2x plus 6 is less than negative 4, and then I'm going to solve for x. So I'm going to subtract 6 from both sides, and when I do that, I get 2x is less than negative 4 minus 6, which is negative 10. So now to solve for x, I need to go ahead and divide by 2. So I'm going to divide both sides by 2, and that's going to give me x is less than negative 5. So that's part of my solution, right? Because remember, there's two pieces to my OR inequality. So now I'm going to go to 3x plus 2, and that is greater than or equal to 14, and I'm going to solve for x. So I'm going to start off by subtracting 2 from both sides. So that gives me 3x is greater than or equal to 12. And now I need to divide both sides by 3. And when I do that, I get x is greater than or equal to 4. So my solution is going to be x is less than negative 5, or x is greater than or equal to 4. Okay, so that's how you describe the solution. We need to include that or there. So now I'm going to go to my number line. So at negative 5, I have an open circle, and I'm going to shade to the left of negative 5. And then at 4, I have a filled in circle, and I'm going to shade to the right of 4. So now let's try solving this compound inequality and graphing our solution. So we have 5x minus 2 is greater than or equal to 13, or negative 3x minus 4 is greater than or equal to 17. So we have 5x minus 2 greater than or equal to 13. So I'm going to start off by adding 2 to both sides. And when I do that, I get 5x is greater than or equal to 15. And then I'm going to divide both sides by 5 to solve for x. So when I do that, I get x is greater than or equal to 3. Now I need to solve negative 3x minus 4 is greater than or equal to 17. So I'm going to start off by adding 4 to both sides. And then after I do that, I have negative 3x is greater than or equal to 21. And now I'm going to divide both sides by negative 3. Well, I divided by a negative number, right? So I need to flip my sign. And so that's going to give me x is less than or equal to negative 7. Okay, so my solution is going to be x is greater than or equal to 3, or x is less than or equal to negative 7. And now let's graph that on our number line. So I'm going to go to 3 and put a filled in circle there. And then I'm going to shade everything to the right of 3. And now I'm going to go to negative 7 and put another filled in circle and shade everything to the left of negative 7. So now you can go ahead and pause the video and try doing this example on your own. So here we have 2x minus 5 is greater than 3. So we can solve that by adding 5 to both sides and then dividing both sides by 2. So that gives us x is greater than 4. When we solve 4 minus x is greater than or equal to 6, remember this is one of those problems that can be kind of confusing because it's a little out of order. But remember that 4 is basically a positive 4, right? So to get rid of that 4, I'm actually going to subtract 4 from both sides. And that leaves me with negative x is greater than or equal to 2. Well, remember, negative x is not, fully isolated yet. I need to get rid of that negative, which is basically like a negative 1, right? So I can get rid of it by dividing both sides by negative 1. And I need to flip my inequality sign because I am dividing by a negative number. So that gives me x is less than or equal to negative 2. So my solution will be x is greater than 4 or x is less than or equal to negative 2. So I go to 4 and I put an open circle and then shade to the right of 4. And then at negative 2, I have a filled in circle and a shade to the left of negative 2. So remember that when you're solving inequalities, you want to first think about whether you have an and inequality or an or inequality. Remember to look at the inequality sign to determine the type of endpoint, so open or closed circle, and the direction of shading.